Now we'll go through the basic problems from the DTFT. So first of all, I'm taking one simple function. This equation is finite function. X of n is 1, 2, minus 2, 1. So one function is defined like this: 1, 2, minus 2 and 1. Find DTFT of the given signal. So first of all, we have to check whether the function is energy signal or not, right? Now the signal consists only 4 samples. And if you find the summation of these two, it gives the less than the infinity because it's a finite function. So this signal is absolutely integrable. That's why directly I'm applying now DTFT. Discrete time Fourier transform of x of n is summation n is from minus infinity to plus infinity x of n into z to the power of minus n, right? So x of n into z to the power of minus n, but the given function, the given signal is defined from 0 to 3, because how many samples are here? 4 samples. Arrow representation is not there. That's why these samples are starts from time is equal to 0. Time is equal to 0, time is 1, time is 2 and time is 3. So the limits of the given function is 0 to 3. So directly I'm writing now x of e to the power of j omega is summation n is from 0 to 3 according to the given function x of n into e to the power of minus j omega n. So here you have to write e to the power of minus j omega n, right? DTFT means in terms of e to the power of j omega representation. If it is z transform, there you have to write z to the power of minus n, right? So now I want to expand this. Substitute n is 0, x of 0 e to the power of 0 plus x of 1 e to the power of minus j omega plus x of 2 e to the power of minus 2j omega, and plus, because summation explains the plus here, so 3 is substituted x of 3 e to the power of minus j3 omega. N is equal to 0, 1, 2 and 3, right? Substitute the values. X of 0 is 1 and x of 1 is 2 and x of 2 is minus 2 and x of 3 is 1. Substitute those values. Then finally you will get the standard equation. X of e to the power of j omega is 1 plus 2 into e to the power of minus j omega minus 2 into e to the power of minus j2 omega plus x of 3 is 1 is there, so e to the power of minus j3 omega. So this gives the complete frequency domain equation, right? So if the function is finite function, here apply the finite limits, then convert it to time domain, frequency domain function, right? One more problem I'm taking now, that is x of n is 3 to the power of n into u of n. X of n is 3 to the power of n into u of n. So now here the a value is greater than the 1. This does not satisfy the absolutely summable condition. That's why DTFT is not possible here. So in this case, it is not absolutely summable. Absolutely summable function. Absolutely summable function. Therefore DTFT is not possible. DTFT is not possible, right? You have to write like this. And one more problem is there. Just I'm assuming all these equations, basic functions. I'm taking different models, different methods here, right? So one more question is like this: 1 by 2 into whole to the power of n into u of minus n minus 1. 1 by 2 into whole to the power of n into u of minus n minus 1. See, now the time limits are u of minus n minus 1. So u of minus n minus 1 means the time is defined from minus infinity to minus 1, negative time axis side. For the negative time axis side, if the a value is greater than the 1, then the signal is a energy signal or absolutely summable signal, right? So I will write those conditions here. A to the power of n into u of n, a to the power of n into u of n is absolutely summable if if a value is less than the 1, right? A to the power of n into u of n is absolutely summable if a value is less than the 1. Similarly, a to the power of, this is another important point, a to the power of n into u of minus n minus 1, if the function multiplies with u of minus n minus 1, this is absolutely summable function if mod a value is greater than the 1. We have to remember these two. Now here, this is not satisfies the absolutely summable, that's why DTFT is not possible. That's why DTFT is not possible for these two problems. Here I am taking one more problem now. X of n is 3 to the power of n into u of minus n minus 1. See, x of n is here 3 to the power of n into u of minus n minus 1. Here this 3 to the power of n multiplies with u of n. It is not a absolutely summable function, but here 3 to the power of n into u of minus n minus 1, it multiplies with u of minus n minus 1. It is absolutely summable function. That's why here DTFT is possible. From this equation I am writing now like this, standard formula is there. The formula explains DTFT of a to the power of n into u of minus n minus 1 is minus 1 by 1 minus a into e to the power of minus j omega. From this, directly I am writing now the DTFT of x of n is x of e to the power of j omega. This is equal to minus 1 by 1 minus a value is how much here? 3 into e to the power of minus j omega. So this gives the frequency domain equation. So to write these type of functions, to find the DTFT from these two functions, we have to check this condition, absolutely summable condition, then we can apply DTFT directly, right? So please take this now.